Welcome, compadres. Today we're talking petroleum engineering. We got a lot to cover, so let's go ahead and jump into it.
Today we're going to do economic forecasting of our decline curves with the ultimate goal of determining net present value using both our oil and gas streams. In particular, this is the model we're going to use or demonstrate today. It's going to basically say that our net present value is going to take into account four factors: our discounted oil revenue, our discounted gas revenue, our discounted operating costs, and our initial drilling cost. If we expand this out in mathematical terms and make some assumptions such as constant oil and gas price and constant operating cost, we get this equation right here. Essentially, our first term is our discounted oil revenue. It's basically our constant oil price multiplied by the sum of our oil rates divided by our discount factors each month over the life of the well. Our gas revenue is calculated the same way, except our gas rate is going to be substituted in with this term right here, our GOR times our oil rate, and then we're going to subtract our operating cost and multiply it by this term right here, which is essentially a discount factor for constant annuity payments. And we've seen this in a previous video, and we're going to subtract our initial drilling cost. And I want to emphasize that we're using monthly data. That's why we can use this nice sum right here. We're going to start at month 1 and go to the life of the well for both our gas and oil streams. So there's two terms in this equation that we're going to need to determine from our analysis that we've been doing. Number one, the oil rate, and then the GOR. So we get our oil rate from a rate time decline curve, and these are our fundamental equations right here. We can get our forecasted oil rate from this point and beyond using this equation right here, where DI and B are constants and T is going to be our incremental months and into the future. And then this is our cumulative oil production from our rate time decline curve, which we're going to use to help us calculate GOR. And if you remember, we can get our GOR as a function of oil rate by linking it to our ARPS equation. We can simply substitute our cumulative oil production up here with this equation down here, and we get our GOR as a function of rate. That helps simplify the calculation tremendously. And I want to emphasize that the reason we're not going to use this early time fit is we're actually going to discount our actual production data. We're going to honor this production data right here, and so we don't need this line right here. The same over here, we're going to honor our oil production data. We're going to discount that first, and then once we reach the last point, we're going to forecast and discount these values right here to the end of the life of the well. So that's essentially what we're doing. We're using these two models to help us determine our discounted oil revenue and discounted gas revenue so we can calculate net present value. In addition, I'm going to introduce you to the notion of the production discount factor. This is essentially basically describes how much of your actual production is being discounted over the life of the well. And to limit the confusion, essentially what I'm going to do is I'm going to take our discounted oil revenue, I'm going to multiply it by the EOR of our oil over the EOR of our oil, which essentially is multiplying this term by 1. And then I'm going to circle this term. This is going to be our oil production discount factor. And then I'm going to do the same thing for the gas right here. Multiply it by the EUR of the gas over the EUR of the gas, and then calculate this right here. If I do that, I can simplify this equation down a little bit more, and we're actually going to, this is what it becomes right here. It's going to be our oil price times our oil discount factor multiplied by our decline curve EUR oil plus the gas price times the gas production discount factor multiplied our EUR gas from our decline curve analysis. and we're going to subtract our operating cost and our initial drilling costs. And I want to emphasize that this oil production discount factor, if it confuses you, you don't have to do it this way. You can use this equation up here, but essentially what it does is when we go determine this oil production discount factor, we're going to actually calculate an EUR, and we're going to compare this to the EUR of decline curve, and if they're similar, then we know we did our NPV calculation correct. If they're not, then we did something wrong. And so it's used as not only as a metric to determine how fast the well is producing, but it's also a metric used to help us validate our model. And this will make sense when we do our Excel analysis, as I'm going to do shortly. But in addition with that, we're going to do an added bonus and calculate our net present value per acre using material balance, because once we have our net present value, we can do that. And then we're also going to calculate a recovery factor using our material balance and our EUR from our decline curve. So guys, let's go ahead and step into Excel and see how this is done. And I think after you walk through the mechanics with me, you'll understand what's going on. So we're going to step into it. We're doing an analysis on the same production data we've been doing in the previous videos. Essentially what we're going to do is calculate net present value per acre, and recovery factor. And we're going to introduce some terms we need to fill in. We're just going to go fill this in with some code, and I'm not going to really go into details of the code right now. We're just going to go through the mechanics, and then after we do that, I'll step into the code a little bit and explain it. But essentially, these are the parameters we need to fill in to calculate net present value, and we're going to use this equation right here to do it. This is what we're calculating, our four terms here to determine net present value. So the first step is to specify an annual discount rate. In this case, I'm assuming 15%. The next step is to calculate our oil production discount factor, and then so I wrote a VBA function to do that. It's called EUR discount factor monthly rate time, and you can see here it's going to take an array of our production data, so we're honoring our actual production data in this case, and I'm going to start at a time value of 1 month. So this is our oil production rate, and I want to freeze those, and then it's going to take our annual discount rate, and then QI, DI, and B from our decline curve analysis or decline curve fit, and then our economic rate. So it's going to return 3 values. I'm going to need this life in months to help us discount our operating cost. And then it returns this EUR oil. So in that code I calculate the EUR or the running sum. And if this value is close to what we calculated in our decline curve analysis, we know that we took into account the right parameters essentially. So it's kind of just a way to validate if we did our NPV calculation correctly. We're going to do the same thing for the gas. So we're calculating this second term right here. This gas production discount factor is what we're going after. So the VBA function for that is EUR discount factor gas monthly, and it too as well is going to honor our monthly production data. In this case we have gas production data as well, and I'm going to start at time of 1 month, and then it's going to take our annual discount, and it's going to take into account our annual discount rate, our QI, DI, and B from our decline curve analysis, and then our economic rate, our oil rate that is, And then it's going to take a couple parameters from our cumulative gas production versus cumulative oil production plot. Remember, we're using this late time fit to do that. So the intercept is going to be this value right here. And then it's going to take into account our slope of that blue line, which is right here. We did this in a previous video, so if you hadn't seen this, please go back and watch that, and you will get up to speed on that. So this is our production discount rate, and if we compare the EURs of our gas, we can see that they're off. So this tells me that something's wrong. I didn't select the right parameters, so let's go back and look. Okay, so right here, see that? We used our oil rate instead of our gas rate here, and see that's why I have that number there right there to demonstrate that to see if we did our calculation correct. And you can see here we selected the right parameters, and we got our result close right here. The next step is to calculate our A over P, and you can do that with an Excel function, PMT. It'll return a negative value, so I put a negative in front of it so it returns a positive value. And it's going to take our rate, and we got to be careful here. This function, you got to have the units have to be consistent, and because we're using months, we're going to have to convert our annual discount rate to months. So I divide that value by 12, and then this n per is going to be the life over which you're doing this calculation, and then our present value, or PV, if we make it equal to 1, then we get this ratio. And then we can do our net present value calculation using this equation down here. It's going to be our oil price. In this case, we're using our net oil price times our oil production discount factor times the EUR of our oil, and we're using it from our decline curve analysis, plus our net gas price times our production discount factor for our gas times the EUR of our gas from our decline curve analysis, and then we're going to subtract our operating cost. That's the third term over here, and that's simply just going to be our operating costs. It's going to be $6,000 per month. In order to get that to the present value, we divide it by A over P, and then we subtract out our initial drilling cost, and we get a net present value for this well. So we use the two streams, oil and gas, and we discounted both of them, and then we calculate our net present value. So now we can determine our net present value per acre. So in a video in the past, I described how we could determine a drainage area using a material balance approach. In this case, we assumed a solution gas drive reservoir that was producing above the bubble point. And essentially what we have here is we have some parameters that you can get from a completion report. I don't have everything, so I use some correlations to get some of these parameters, but some things that we can get from this analysis or our production data is our initial producing GOR and our cumulative production to the bubble point. So if we fill those in, we can fill those in from our cumulative gas production versus cumulative oil production plot. And I'll calculate these. You can go look at the previous video to see how this was done. But this is our initial gas oil ratio. And then our MP to PB, calculated that too, is this value. And so what we get from that is we actually get original oil in place and drainage area. So it's saying this well is draining 165 acres. Now that we know that, we can calculate our net present value per acre. So We have our net present value divided by the drainage area, 165, and we get our net present value per acre. So $5,802. So if we were to buy that acreage at that price, or if we were to bid on acreage for that much, we'd expect a 15% return over the life of the well. So now we can also calculate our recovery factor. So when we did that analysis right here, we got original oil in place. And so if we take the EUR of our oil and we divide it by the original oil in place, we get a recovery factor. And it's saying right here that we expect to recover close to 5% of the oil in place. So that's how we did it, guys. So we went through, we calculated net present value per acre, and recovery factor using a plethora of tools. So now we're going to go ahead and step into the code to show how we calculated some of these things, such as production discount factor and production discount factor for our gas stream. So let's go ahead and look at the code. So we're going to go ahead and step through and explain kind of how the code works. We're going to start off with our oil production discount factor, how we did that, what parameters we took into account. You can see this is the function that calculates our production discount factor for oil. It takes our monthly production data, our annual discount rate, parameters from our decline curve, and the economic limit. First, we want to discount our monthly production data, our actual data from our decline curve. So we start off and we count how many months we have of actual production data, essentially, and then we go ahead and we discount our annual discount rate to a monthly discount rate because we're working in months, and then we calculate a life using some of ARP's equations. We've seen this in the previous video, and then this is where we start our production discount factor calculation. So we start with our actual production data from the first month to the end of our last point that we have of physical data. You can see here we have our discounted EUR. It's a running sum. It takes our monthly production data and then essentially divides it by our discount factor, or multiplies it by our discount factor, and then we calculate a EUR as a running sum to compare it to our decline curve analysis to see if we're doing it right. So we started off, and we basically, if we go over here, we're doing this region right here of our production data. So once we have discounted our production data up to this point, then we jump into our forecast, and that's what we'll do next. Is we go through on the next for loop, we go from the next future point in time from our last production point to the life of the well, and we begin to use our ARP's rate to calculate our future rates in time at the given months, and we discount those values. And once again, we're doing a running sum here, so we jump from this down to here. We continue to discount to the end of the life of the well, and we continue to calculate a cumulative production. After we've done that, we return our production discount factor as our first parameter right here. It's our discounted EUR divided by our cumulative EUR that we calculated from our for loops, and then we return the life of the well and the cumulative EUR as shown in these boxes right here. So that's all we did, and then we return those, and we're done with that function. Next, we're going to step into the gas code, how we calculated these values over here. our production discount factor and EURs of our gas. And so it takes in similar arguments. The only difference is we use our cumulative gas production versus cumulative oil production plot, in that we calculate, or we need our slope and intercept of our late time fit. That's the only difference. You can draw parallels between the previous code, or the oil production discount factor code, and the gas production discount factor code. We start off with the same procedure. We calculate how many months of actual production data we have up to this point in time, and then we convert our annual discount rate to a monthly discount rate, and then we round that value. And the reason we round it is because we're dealing with months, and when we do our discounts, we're doing it by month, and so our economic limit may not end on a integer value, so that's why we round it. And then we begin to discount our production data. So we discount our actual production data in this loop, and also calculate a running sum of our cumulative gas production data. And then in the next for loop, once we've reached our last production data point, then we begin to use our forecast. And once again, we need to calculate our GUR from our oil rate, and that's what we're doing in this case. This is calculating our GUR from our oil rate, and it's the equation we saw in the slides. And then we continue to do a running sum of the discounted values and a running sum of the cumulative values, and essentially from those two values we determine our gas production discount factor, and then our cumulative EUR for our gas that we use to compare to our decline curve, and then we return that, and we're done. But these functions right here that I called up here, we've seen this one, ARPS rate, and then I believe we've seen this one up here, rate time life. But if you haven't, I'm going to show them here. So this is our GUR from rate. It takes in these values. It's essentially describes that process I described in the slides. It takes our cumulative production from our ARPS, and then it plugs it in here to help us calculate our GUR at future months and time. And then our rate time life comes from ARPS equations. So guys, that's pretty much it. That's how the code works. I hope going through it, stepping through it, you can kind of understand what was going through the thought process of designing this template. But yeah, that's all I got today, guys. I hope you learned something, and I'll see you next time. Adios.